In this session, we have three distinguished speakers, Professor Dr. Weckenman, Professor Dr. Durakbaşa from TUV, and also Professor Dr. Fatih Taşgetiren from Istanbul Yaşar University. Please first welcome Professor Durakbaşa, who is going to present the co-work of Professor Weckenman and Professor Durakbaşa, named Intelligent Design and Advanced Methodology based on Geometrical Product Specification and Verification in Precision Manufacturing.
Thank you very much, dear distinguished guests, dear colleagues, ladies and gentlemen. I'm going to talk about this topic here today. I'm very pleased to present this work with Professor Weckenman. This is a common work that we are in very close cooperation, and the subject will be here in the Intelligent Design and Advanced Metrology. And this presentation proposes a strategic approach to develop and advanced metrology and intelligent quality management applicable in Industry 4.0 by integrating, on the one hand, the intelligent precision metrology and also based on the geometrical product specification and verification with the point of the functional oriented evaluation. What does it mean? We want to look general here. The table of content will be after introduction with the design process, product quality and process quality, and the accuracy of the workpieces can be here achieved using the concept of GPS. This is the Geometrical Product Specification and Verification. And the developments in this field with the intelligent products and also in the design and metrology, and on the other hand, the development very fast into the direction of micro and nanoscale manufacturing. This will be also here one point, especially in the question how we can make the design specifications and also the verification according to the functional oriented system. This will be then also for the future work one of the important points to make the further process and development in that direction. The idea here is to integrate of the different systems, as we can look at for a modern integrated system which will be based on the intelligent quality system, which provide the opportunity to improve the product and process quality, and also to avoid mistakes in the process, and also discover this as early as possible after their emergence. So is the in the central position we have the intelligent integrated system as a manufacturing system with a process approach that is the requirement of the quality systems in modern quality systems. And also the new additional subject will be here, so-called risk-based thinking. And the whole system consisting by different management systems in the meantime, where we are speaking about the environmental side with the environmental management system according to the international standards, as well as the energy management system, and also it's in that context with the Industry 4.0, the information security management systems. And additional point is the risk management in the same way, and also, of course, the occupational health and safety management system, also according to the new international standard 45001. The idea is here looking for the product realization steps, starting with the planning area over the product realization, and then afterwards the consumption, and after use the part of this cycle as end of life management. And here for an efficient product life cycle management involving simulation, modeling, and also knowledge management from the product conception and development stage down to the manufacturing, verification, and the maintenance, recycling, that means the end-of-life management. Well, the metrology, this is here 40 years, they have noted the increasing importance of the sophisticated production metrology as a means to control industrial manufacturing and also to test technical product with high accuracy on the basis of geometrical product specifications and verification, and also to improve the quality of all kind of products and processes. The development started already more than 100 years ago with some very important essential developments in the field of metrology, as we can use this today also as a basic metrological systems, as from Abe in 1890 with the comparator principle to avoid the first order of measurement errors, and then the development in the interferometry with Michelson, and then Johansen parallel gauges, and Winslow-Taylor 1905 principle for the go and not go gauges. So we can see here at the turn from 19th to the 20th century, there have been various basic inventions like this that we are counting now in the field of metrology, especially, of course, as far as for geometrical measurements are concerned, but also in the field of quality control, especially. Short looking the system, this model concept of the GPS, also according to the product realization steps with the design and product development, the manufacturing and the verification, and they are such geometrical specifications which are necessarily to set up for the workpiece accuracy and also evaluation of the product quality. The system also, of course, here in nearly all technical areas, the main aim of the measurement process is not only testing the conformance of the features value with the specification. The real intention is the predictive assessment of the functional ability. So it's necessarily here in order to understand the background of today's concept of the GPS. This will be here looking at the historical development, how on the one hand the manufacturing accuracy developed from the 1820 up to today, and also the looking for the next feature, how they will be developed in the next time. The uncertainty of the measuring processes, this is also, of course, important point, and so is also the development can be seen here on this slide very well. For looking now, how is going according to the GPS concept on the one hand, if we are looking now for the three-dimensional tolerancing on the workpieces, and with these intelligent systems, metrology and measurement systems, using advanced metrology, artificial intelligence especially, and also of course IT, in order to optimize the design of products and production systems for an efficient product life cycle. Management involving simulation, this is important for modeling and knowledge management from the product conception, as we know already, manufacturing, verification, maintenance, and recycling. So is the sequence that we can follow, starting from the needs and expectations from the customer side, to define what are the functional needs, and from the functional needs is the driving to the functional specification, and the next step can be derived from that to the geometrical specification. And now we have here in the design stage the already set up geometrical specifications, and so we can set up according to these specifications the features which will be measured, that means the quality, and to evaluate the measuring results to compare also with the geometrical specifications which are already set up. And so is the looking for the steps now, product development steps, process steps from specification to verification, starting as we see now, the functional requirement, functional specification, geometrical specification. So we have on the one hand the for the manufacturing specifications, the parameters, and according to this the manufacturing part, and on the other hand, parallel to this, we can get the measurements for in this process. Afterwards, we have the measurement evaluation, and here the stage at the moment is the design-oriented verification, and for the next feature, more and more from now on, the function-oriented verification necessarily. So is the area, and also the combination from design to production, and afterwards the measurement. So we can see here, first of all, setting up a model of the function. This is done while developing the part or device with the advantages in the design process. This is the approach for optimizing refined geometrical requirements, and for the manufacturing process, scrap due to exaggerated small tolerances is avoided. More, and that means also for more freedom of the manufacturer. And in the verification process, we can use the mathematical physical model with the measured quantities. The functional behavior can be simulated based on the realistic data. This is the main point, and they are also the area in the macro geometry. The main function in the macro range is the mating ability. So to verify this function, the evaluation methods, they are can be seen here in the different forms, where we could use here the maximum inscribed condition and also the minimum circumscribed condition. These are the popular methods to get this function-oriented verification. This is the one point. How is looking now in the micro and nano scale manufacturing? This is, of course, one important point, and is a big challenge for the next time. Also for the verification part for measurement and metrology. Here we can see now also in the combination with the geometrical specifications is also additional features can be get using these technologies in micro and nanotechnology, as we can look at now for the functionality on the one hand, and also use, of course, on the base of the GPS concept with the geometrical product specifications and verification, concerning the needs for the functional oriented verification, specification, and also, of course, verification. This is of course possible only using the intelligent and sophisticated measuring instruments. So we can see there are some instruments in that area at micro and nano scale. In macro geometry, there can be seen here as a high precise bearings, air bearings as object can be checked by high accurate coordinate measuring machines. They are here air bearing diamond turned air bearing spindle as example here in our slide, with ran out deviation by 0.2 micrometer, and in the micro scale measurement, the surface structure according to the international standard again as 10 nanometer RA value. So the applications here with sophisticated instruments, they are necessarily because, of course, the measuring devices must be more accurate than the machine parts. This is the important point. And at nanoscale, there are instruments developed meanwhile as surface topography measurements by SEM, scanning electron microscopes, or also by atomic force microscope. And we can see here also the development which are now faster and faster in the sensor technology for sophisticated instruments like optical technology today with scanning probe microscopes and X-ray tomography. This is a also very important instrument for especially in the frame of the Industry 4.0. And so we can see here the examples and also the application area with the resolution in vertical and lateral directions in our slide. The nanotechnology, this is a EU strategy, has defined the nanotechnology as one of the key enabling technologies for growth and jobs. And so the problem for the manufacturer, that means to meet high level demands, both from the industrial on the one hand and also from private customers in the future. The companies must be flexible and agile enough to respond quickly to product demand changes, also according technological development, especially in the field of precision engineering at micro and nano scale production. And so is looking now for the different methods, machining methods. We can see here also the different surface structures. This is an example from the cylinder liner in the automobile industry. And its important point is the functional testing, which will be and must be carried out. And this is also, of course, in many disciplines, in the also industrial fields, in the manufacture of the aerospace, for example, components, and also automotive industry, as well as the rigorous testing of the medical devices. And here we can get such surfaces after precise machining. This is the matching of the own cylinder liners with the pistons and piston rings. This leads to improved results in the engine. This is important for the good functioning of the machine, of the engine. And the optimal function of the respective part is supposed to be guaranteed considering certain manufacturing tolerances. Therefore is here the idea in that case, especially at micro and nanoscale structures in the precision engineering, which are the examples, the routinely implementation of such tests is which are very extremely important to ensure the functional capability of the products. And here, from the metrological side, we can get here these surface structures using sophisticated instruments, and to get here the parameters to evaluate the surface, and additional point will be then in that case to look for the functional specifications, and according to the functional specifications to get the functional evaluation. This is on the one hand the direction at the micro and nanotechnology to get the surface structures, atomic and molecular level. And on the other hand, in nanotechnology, we can see the development in the miniaturization. Here in that case, we have the example using the method of two-photon polymerization technique to fabricate 3D structures with resolution down to 100 nanometer, which is exactly in the border of the nanotechnology to microtechnology. So is here the problem, of course, on the one hand, to get this product, sorry, maybe first of all, we can look at this video can show us using scanning, laser scanning instrument to get the 3D model on the one hand, with, of course, we can see here the main distances. This is the length in maximum length is about 0.67 millimeter, and on the other hand, the width and the height is 73 micrometer, and in the other direction there is only 130 micrometer. To look now in that area, that we can see the concept of the GPS could be and will be applied here to get, according to the geometrical specifications, such products, but on the other hand is of course necessarily to have this function-oriented specifications and verification. As we can look at for the conclusion, so we can see here the next generation production systems should integrate precise measurement systems on GPS and 3D metrology to provide not only solution to overcome production challenges, but also for more efficient use of the resources, for the protection of the environment, of course, and improved process control, better product uniformity, fewer waste, enhanced safety, and also other sustainable benefits. Then we can see here with this model as proposed here in this presentation, this will be used on the basis of intelligent metrology in all production processes in such a system, from the design stage to the final assembly and from the after use to recycling. And such systems can play a basic role to ensure the realization of the concept, to create, to realize, and also to present the features such as concurrent, interactive, modular, integrative learning, autonomous, and self-optimizing and self-organizing functions. It's here, of course, the important question in that case, how we can apply this model, this concept, also in the platform of Industry 4.0, not only in large production complexes, but mainly in the SMEs. And the inspection, which will be by modeling and simulating the functional capability based on the measurement results, and also the functional mathematical physical model of the part and product. So, thank you for your attention.
We kindly invite Professor Weckenmann to the stage, please, and also Professor Genç Yılmaz to present his plaquette.